All right, good morning and welcome back. Today we are going to talk about something called the distance formula. So we'll get that in a little bit. But first, if we look here, it asks us to find the area of the parallelogram. Now, this would be pretty easy if we knew the formula for the area of a parallelogram. Unfortunately, that's not one of the ones we covered. We talked about the area of a triangle, the area of a square, even the area of a trapezoid, but not a parallelogram. Now, some of you might know it, and if you do, you can already find it. But if not, let's think how we can divide this into a shape we do know. So if we draw from S across to Q here, and let me redo that, that's not the best line. You'll see now we have two triangles formed, okay? And if we look here on the bottom, from -6 to 1, so that's going to be a length of 7. The height here, 1, 2, 3, 4. And I don't know if you guys remember, but our area formula for a triangle is 1/2 times the base times the height. So our base is 7, so 1/2 times 7. Our height is going to be 4. So if we multiply all that together, we'll get 14 units squared. Okay, that would take care of this triangle over here on the left. Now the good news is for our other triangle, the height is still going to be the same, 4. Base of that other triangle is also 7. So many of you can probably guess 1/2 times 7 times 4. It's going to also be 14 units square. All we have to do to find the whole area, so that would be this blue. So we add the red and the blue together, we get 28 units squared. All right, now those were easy because we could find the height and the base just by counting because they were horizontal and vertical. Sometimes we're asked to find the distance between 2 points that are not in line with each other. Do you see how here it's on the diagonal? And you might remember when you see this right triangle, Pythagorean theorem. So that would be like a squared plus b squared equals c squared. Now instead of that, we're going to kind of convert the distance formula here. But it's the same thing. A would be the distance from x to x. So if we take x2 minus that x1, and we square it, that's a squared. B is y, up and down, so that's y2 minus y1. If we square that, and we take the square root of both of these. So if we think about it, a squared plus b squared equals c squared. We'd take the square root of that and the square root of that, and the c would equal the square root of a squared plus b squared. Okay. So now, let's use this formula. Let's first identify what our points are. So in an ordered pair, hopefully you know we have an x and a y. So this is our x1, our y1, our x2, and our y2. And we'll plug them in here to this formula. So the square root, and then it's going to be x, so -3 minus 0 squared plus, and we'll take 6 minus 3 and square that. So now we simplify. -3 minus 0 is -3. We square that, and that'll be +9, because remember, negative times negative is positive. 6 minus 3 is also 3. 3 squared is +9. Add those together, square root of 18. Okay, now to find the approximation, we can go to desmos.com/scientific. Looks like I already did it here. Square root of 18, 4.24. Okay, so that's going to be one option. All right, so as we see, square root of 18 here, we get 4.24. So if we round, it's about 4.2. Now I'm going to put this squiggle equal because it's approximately that, 4.2. Now, one thing we want to talk about is what if we needed the exact answer? So if we had the square root of 18, and we had to break this down, we need multiples that give us to 18. So that'd be 3 times 6. 3 here, 6 breaks apart to 3 times 2. We have a pair of 3's here. That comes out front. 3 square root of 2. That would be the simplified version right here. Okay. So this is just kind of a refresher. We did this in the past, probably in Algebra 1, but just a reminder, that's how you simplify a square root if it's not a perfect square. All right, example 3 says find the perimeter and the area of this triangle. Okay, so let's start off the easy side. Well, first perimeter. that's the length of the three sides. So the easiest one, pretty obvious, I hope, here from C to B, we can easily count that. We count that 5 plus 5 gives us a length of 10. Now, that's our perimeter. We also need to figure out what these other sides are because we need all three sides to get the perimeter. So from C to A here, let's start. A is at the point 0, negative 5. Or sorry, not 0, negative 5, 0, 5. If you're not sure how I got that, it's left and right 0. It's up 5. Then C is at left 5, down 5. So negative 5, negative 5. All right, and now we can use the formula from above that we had. So the one right here. So the square root, we'll do negative 5 minus 0 squared plus negative 5 minus 5 squared. So the square root of, it's going to be negative 5 squared, which gives us 25. Over here, negative 5 minus 5 is negative 10. If we square that, we'll get 100. Then combine our like terms, square root of 125. So that's our distance. Now that's can be reduced, so we'll take square root here of 125. That's approximately 11.18 or 11.2. If we wanted to find the exact answer, though, that'll work for this problem. But if we needed the exact answer, we would have to break that down. So break it down, 5 times 25. 25 is 5 times 5. 3 5s, meaning we have a pair of 5s and one extra. So that'd be 5 square root of 5. But for now, we can just call it 11.2. Now, the other side is actually going to be the exact same. Okay, just to save us a little time, we could do the process again. You can see it's an isosceles triangle. So that's 11.2. So area, we'd add those up. 11.2 plus 11.2 is 22.4. Plus that, 32.4 for our perimeter. That'd be 32.4 units. Now to find the area, 1/2 base times height. So let me do this in blue. We know our base is 10, so 1/2 times 10. The height here, we measure from the bottom to the top, also 10. Half times 10 times 10. The area will be 50 units squared. All right, we're almost done. Final one we're going to look at today. Asks us to find the area of the dark green shaded piece. So that's right here. There's also the light green, but we need the dark green. Now, when we look at this, the first thing I want us to notice, what is the biggest possible answer we could have? And if we think about it, maybe this isn't the right way to phrase it, but if we look at the light green, you see how it's 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5. So if all of that was included, 7 times 5, that'd be 35 units squared. Now, that would be if all of this was included. We need to then figure out what each of these areas will be of these 4 triangles, and we can subtract them off from that 35. So we'll have to do it 4 times. We know our formula for a triangle is the area equals 1/2 the base times the height. So at the top left here, the height here is 2, the base is 3. So let me do this in red. 1/2 times 3 times 2. That will equal 3 units squared. Bottom left here, height of 3, base of, let's see, 1, 2, 3, 4, 5, 6. Okay, so if we do that, we will then get 1/2 times 3 times 6. So that's 18 times 1/2 would be 9 units squared. Okay, over here we're going to have 1 for our base, 2 for our height. So 1/2 times 1 times 2, which will end up being 1 unit squared. And then finally up here, height of 3, base of 4, 1/2 times 3 times 4 gives us 6 units squared. Add all those up. 9 plus 1 is 10, plus 3 is 13, plus 6 is 19. That's the total of the light green. Now all we have to do, 35 minus that 19, give us 16 units squared as our answer. All right, hope you have a great day. Let me know if you need any help, and go ahead and finish up the delta math from the other day.